Morning everyone. Our topic for today is logical contradiction. So, our learning objective is at the end of the module, the students will be able to construct through tables prove that a statement is a contradiction. So, hello everyone. Once again, I'm Mariahani Grace A. Datu and my partner is Elvie and Cagampang, your reporter for today's topic, module 4. So, before we formally start, let me share with you our quote of the day. Stay away from those people who try to disparage your ambitions. Small minds will always do that, but great minds will give you a feeling that you've become great too, by Mark Twain. So, let's start. What is contradiction? So, a logical contradiction is a conjunction of a statement S and its denial not S. In logic, it is a fundamental law, the law of non-contradiction, that a statement and its denial cannot be true at the same time. So, in another term of contradiction, it is also a logical incompatibility between two or more statements or propositions. It occurs when those statements or propositions taken together yield a falsehood. The simplest or classic form of contradiction is the assertion both of some statement or proposition and its negation. So, for example, I love you and I don't love you. Number 2, Batch is married to Barb but Barb is not married to Batch. Number 3, I know I promised to show up today but I don't see why I should come if I don't feel like it. So this example all seems to be a contradiction because they seem either explicitly to state or logically imply a certain statement and its denial. So number one example is an explicit contradiction. You can't love someone and not love someone at the same time. And number 2 is also an implicit contradiction. It depends on the unstated but well-known principle. If X married to Y, then Y is married to X. Number 3 is also an implicit contradiction. It depends on the unstated meaning of promising. Namely, that whether you promise to do something, you thereby acquire the moral obligation to do it.
So what is explicit contradiction?
Argument is deductively valid if an explicit contradiction, the conjunction of a formula and its negation, is derivable from the premises of the argument together with the negation of its conclusion. Implicit contradiction is also a single statement or pairs which in some way imply, entail, or commit us to explicit contradiction down the line. That something is an implicit contradiction may thus be far from obvious.
Hello everyone, I'm Elvie Cagampang. I'm going to report this part. Show that the statement P or Q and the statement of not P and not Q is a contradiction. So, we can find the solution in this problem by using the truth table. So, here as we can see, we have the P statement, Q, the not P, not Q, P or Q statement, the not P and not Q statement, and this part. So, we need to prove if this one is a contradiction. So, contradiction is the opposite. So, first, why it becomes truth. So, based on the truth table, this one is given. So, the P statement is true, true, false, false, and then the Q statement is true, false, true, false. So, for this part, this is only the opposite of the P statement. So, truth, it becomes false, true, false, false, true, and false, true. So, it's same goes to this not Q statement. So, we just get the opposite of this part. So, that's it. The true, false, false, true, true, false, false, true. And this statement is based on this two part, the P and Q statement. This is OR, so we need to get the answer of this one. So, the statement here, it is true, true, so obviously it's true. And if the first statement is true and then the second statement is false, so it is always true. So if the statement is false and the second statement is true, so this is true. So the last one is false, false, so it is obviously it's false statement. So on this part, it is only the opposite of this part because this is not P or not Q and not Q. So you can see here they are all true, so it becomes false. So the false become true. So on this part, which we just only look at these two columns of the table. So if it's false, if it's true and then the two statements are contradict to each other, so it is always false. For the contradiction statement, so it is become false if they are all contradict to each other. So therefore, this statement is a contradiction. They are all false. But what if the result here are true, false, true, false? So we cannot conclude if it is contradiction or tautology. So it is called neither. If there is a combination of false and true, so it's neither. So this is how if the statement is all true, so it is tautology statement. So this is how we prove a contradiction statement. That's all. Thank you.